Dear students, the next important properties of the material that we are going to see, the ductility and malleability. So, what is mean by the ductility and malleability? So in general term or in general word, we know that what is mean by this ductility, that is, it is nothing but the elongation or to draw the wire from the given material, that is the ductility. Whereas the malleability is nothing but to have the sheet from the given material, isn't it? So it is ductility. Now in standard word we can say it is the property of the material undergoing deformation when subjected to the tension or the tensile load up to the fracture. What is mean by ductility? So ductility we can define like this. Ductility we can define like this: the ability of the material to undergo the deformation up to the failure when subjected to tensile load or tensile loading. So this is the ductility. In general word we can say that this is the elongation in the given material. This is the wire forming from the material. So here if we talk about in simple word, again we can say that, so it is nothing but the percentage increase in the length of the material, isn't it? Percentage increase in the length of the material. That is, we can define the ductility like the percentage increase in the length, that is L final minus L original divided by L original into 100, isn't it? Say for example, this is the specimen, isn't it? Having the original diameter D original, original length as L original, and we are applying the tensile load. So what is going to happen here? So see, its diameter is going to reduce, isn't it? And what is going to happen? Its length is going to increase because of the applied tensile load. So see, this is the final length and this is the original length. This is the percentage increase in the length, or in the other fashion we can also call it as the ductility is nothing but percentage reduction in cross sectional area. So how can I write? So this is either percentage increase in the length or percentage reduction where in the cross sectional area, that is say A original minus A final divided by A original into 100, isn't it? So this is nothing but our ductility. Now see here, one thing is very important. What is this value? The change in length L final minus L original divided by L original. This is L final minus L original is delta L divided by original L. So what is this? So this is nothing but the strain, isn't it? So dear students, this percentage increase in the length, you can have the strain into 100, isn't it? So sometimes, of course it is in percentage, please remember. So sometimes the engineering strain, because why it is engineering, it is not true, because whenever I am talking about the percentage, so it is always compared with the origin. So please remember that sometimes you can also express the strain that is engineering strain, which is equal to change in length divided by original length in terms of directly percentage. Suppose I am saying that, so in this process of this deformation or metal forming process, I am having the strain of normal strain of say 0.35. So I can write the strain directly. I can say the strain of 35% also, or the elongation of 35%. So this percent is nothing but your strain, isn't it? So डक्टिलिटी में क्या होता है, लेंथ जो है इंक्रीज होती है, डायमीटर जो क्रॉस सेक्शनल जो एरिया है वो रिड्यूस होता है, एंड दैट परसेंटेज आइदर इंक्रीज इन लेंथ और डिक्रीज इन एरिया is nothing but our ductility. In general, we can say it is nothing but wire drawing, isn't it? Wire में convert होता है, material से क्या बनती है, wire बनती है. Next property that we are going to see, that is the malleability. So dear students, now let us talk about the malleability. So how can we define this malleability? So this is the ability of the material undergoing the deformation up to the failure. Under which kind of stress? Under compressive loading or compressive stress, isn't it? So this is nothing but the malleability. In general, we can say that malleability is what? The converting the material into form of sheet, isn't it? So for example, if you take this aluminum, copper and the gold, which are having very good malleability, isn't it? So if I have the specimen here or the material here with the initial diameter D original, with the initial length L original, and if I apply this compressive load on it, and I'm going to have the increase in area, isn't it? So this is nothing but my D final, and at the same time, of course, because of compression, the length is going to decrease to the L final. So how can we define this malleability? It is nothing but the percentage increase in area, cross-sectional area, isn't it? So that is A final minus A original divided by A original into 100 percentage, or in terms of the decrease in length, how to calculate decrease in length? That is L original minus L final divided by L original into 100, isn't it? So in this fashion, we can able to have the malleability and ductility. Please remember that if you talk about the ductility, so ductility of some ferrous, non-ferrous materials is again very good than the ductility of the ferrous materials. If you take the example of aluminum and copper, they are having very good ductility. And if you talk about the malleability, the gold, silver, copper and the aluminum, they are having very good malleability, isn't it? So these are two very important property of the material, that is ductility and malleability. Thank you.